The deal is all, this PSU is now complete. I got it all fused, got the transformer and the heatsink mounted in there, the diode on it. That's perfect. It worked out very well. I've set the current limit to 10 amps. I'm going to put a 5 amp fuse in that secondary. The 8 amp, I've got to put up a 5 amp on it next. Haven't got any spare fuses, so I'll whack a 5 amp fuse on there for some extra safety margin for that transformer. But it's a lot, yeah, a lot better now. More improved, so it won't burn a transformer right now. It's got plenty of safeguard now, so that transformer does have more push than the other one did, so it's getting well protected. Of course, I've got this bond battery here to convert to alum. I just gave it the salt neutralisation treatment, bicarb soda in there. Okay, I'll get this hose turned on. I'll just rinse the rest of this off. Let it all stop bubbling, neutralise with that. Some say you don't need to do that, but I've read, yeah, it's important to do that when doing the alum conversion, because that battery's been desulfated completely now. Yesterday I noticed the fluid levels have actually gone down quite a lot in all the cells, so when that happens, that's it, the battery cannot be desulfated no more. That's actually boiling off all the sulfuric acid in there, so that's pretty much fully done. What the bicarb soda will do, not only neutralise the acid for the conversion, but they'll actually break down even more of the lead sulfate that's in there. The remaining lead sulfate will be broken down and washed out. Now this is going to have to be my container. I've dumped it all in there, let the lead content settle to the bottom. When it's all settled to the bottom, then you can safely pour off the acid. Neutralise it though, you don't have to, but it's best to keep it neutralised as much as you can. The important part is, do not let the lead go into the environment, because that'll go into your food chain and kill all sorts of things, and you can give next generations of people who have lead in them, you know, that happening. So the best method here, have a container set aside, let it all that lead content settle to the bottom, and then pour off the acid. It's all too contaminated anyway. I was going to keep the acid clean and just keep it in a bottle somewhere, but fixing up other batteries like this one, but nah, I'll worry about it. This had a big hole blown in it. It had been crushed or something in a crashed car or something. The plates are intact, but I just got the MAP gas out and welded the hole back up, and that actually worked good. That battery's stuffed. All the positive plates are just ripped off, so that proves the concept. I can weld that sort of plastic really good with a MAP gas and a knife and just pasting it and sealing it. That way it worked good. This one here, well, I get about 150 cracking amps in this. Despite this, the plates are very warped and degraded, but I'm amazed it's actually doing something. This has been next to the alum conversion. That's got about 160 cracking amps left in it, so that'll be converted next. This will be a challenge, it's so damn big. Anyway, let's get this battery all rinsed out, ready for the conversion. Okay, let's test it now. So I'm expecting it to be pretty flat now, obviously. Obviously I got all the acid out of it and neutralised it, so I'm not going to get much power out of it now. Ah! Ooh, the Century one dropped down to 9 volts. That's not bad. Alright, that's a good result. It's only gone up by 10 milliohm. That's not bad at all. Let's give it a top up. Yeah, that one there is recovered quite well on Epsom salt. Let's give it the C-Tech treatment now, actually this one here. They can't desulfate it anymore because the sulphur's gone. So I have to put this on it and put a linear charge on it at the same time. This can't really recognise it after a while, so what I'll do, I'll put this on it as well to stop it from tricking this charger up. That's what I did with the Century battery. Anyway, tomorrow I got another score of meters. Not a hell of a lot this time, but another box, just one box, a couple of SD, I think there's a BAZ and some M1s in there. And I got it some a 3-phase rotation tester, a multimeter, this one. So some interesting scores on tomorrow's meter score coming up. Alright, to help it so it doesn't drop. Okay. A bit of a spark on that. Let's boost it. There we go. This is going to force some of the alum to precipitate in there. That's pretty good. Starting to bubble on all cells, which is good. Looking good. Excellent. Excellent. It's a pretty eco-friendly way to recycle batteries. And that's all going to have to be let that settle, then pour off the clean acid that's been neutralised. All that brown stuff has to settle to the bottom and be disposed of separately in the recyclers. Or I might have a go at just collecting it up and just melting it down with a matte gas. Make it a solid so it's not so much of an environmental hazard. Then dispose of it. Probably be a better idea. Because when it's a powder, it's obviously going to be more risk of contaminating things. But when I melt it all down to a solid, it's a lot less likely to contaminate things. So it's probably a better idea of protecting the environment that way. A fun way to do it too. Also, keep your pets away from things like that. If you've got pets, keep them well away from things like that. You don't want them drinking that stuff. It'd be nasty. Anyway. Yeah, I do kind of regret leaving my other alum batteries behind. Someone asked and watched my alum conversion video before the first batteries I did. Someone asked a couple of months ago, how are those batteries today? Well, yeah, I've left them behind at the old place when we moved here from the old house, so from the farm. So I should have just packed them up and put them in the container, but I just brought them here in the ute. I should have done that, but I regret it now. Anyway, I've got more batteries to get anyway. This one here is actually a lot better condition anyway than that one there, than the other Century ones I had the first time. Except for that Hilux battery, I put a screw in and fixed it. That one there was actually practically still new. I could have at least kept that one. Anyway, that's pretty good. Anyway, so this time I got some solar panels. I'll check this one on camera actually. Let's see how the solar panel goes on that. This is the first time I've actually did it on a solar panel. I've not yet reformed this yet. I've got to drain it completely dead and then recharge it to form it properly. I'm just, yeah, got it done the solar panel as an experiment. See how the solar panel charges this thing compared to before. As you can see, the solar panel does well. Not bad. The solar panels are actually doing auto charges. Actually better than it was originally, because it's easier to take a charge. Yeah, so that's probably only forming the cathodes, I think. When you drain them flat, which we'll do with this one too, we'll drain it flat. Draining it flat will form the positive anode plates with the alum. So the last alum batteries that I did that process, I flattened them and then recharged them again. You can cycle them to 3 or 4 times to make it really good. But we'll see what happens. I've got some, get these things, this one charged right up first and that one is charged right up. I'm going to put these together and I can just chuck them in the corner and flatten them overnight with a big light on them. And just cycle them again. That'll activate it properly. This one was done with distilled water too. This one was done with just tap water. Tap water, the town water's got fluoride in it, so fluoride. It's good for your teeth, so it should be good for the battery too. Stops teeth getting cavities and stuff, so it should do very well to protect those plates from getting cavities and holes. Be interesting to see how it goes in there. It's good for your teeth, it's good for the battery. Anyway, that'll be enough for now. Thanks for watching.